Today we're going to be talking about 1.1e, arc length and area of a sector. I have a lot to cover in this 15 minutes of the video, and so if I am writing too quickly, please stop and pause and make sure you're keeping up with everything, but I'm going to try to do a lot of pre-writing on my own so that my video doesn't take up a ton of time. So the first thing we're going to talk about is theta. Theta, again, is our central angle. We've talked about that over the past few days. R, as you can guess, is our radius. S is our arc length. So if we have a picture like this, obviously our radius is going to be the same on both sides. Theta is the angle inside, and the arc length is S. So if I ask you to find the angle for the picture below in radians, we are going to take the formula theta equals S over R, and theta equals S, which is 7 over 4, and again, this is in radians. Okay. On your own, find theta with this picture right here. Again, theta equals S over R. The arc length is 141. The radius is 27. So 141 over 27. However, what direction did our angle go? So it should be a negative 141 over 27. One thing I wanted to make sure to stress to you is the central angle also always has to be in radians. So if you're given it in degrees, you need to convert it to radians. Okay? All right, the second type of problem we're going to look at is finding the length of the arc. Now again, if you recall, our formula was theta equals S over R. I can rewrite this formula for S equals, and multiply both sides by R times theta. Or I could rewrite it for R, divide both sides by theta. Okay, so you can rearrange this order every time, but again, remember theta has to be in radians. So if you look at this first problem, it says find the length of the arc. Remember, that's S. So if I'm trying to find S, I'm going to use this formula right here. S equals the radius times theta, which is 180 degrees. However, we need to convert 180 degrees into radians. So if I'm trying to get rid of degrees, degrees is going to go on the bottom, pi on top, degrees cancels, and I get 180 pi over 180, which is pi. You should have probably already known that, but just to remind you on how to convert. So now S equals 14 inches times pi, or that is our arc length. You can leave it like that, or you can find out what 14 times pi is, and that is approximately 43.99, which would make a little bit more sense for us to measure an arc length like that. All right, try this one on your own. Pause it, and when you are done, you can look up and see my answer for that. Okay, this one was a little trickier because theta was 4. Remember, if there's no degree symbol, that means that it's in radians already. So all you needed to do here was take 4 times 121 meters, and the arc length would be 484 meters. Okay, so here's one of those problems I was talking about. You might need to pause before I actually do the math for you. But find the distance between two cities, and we assume that the Earth is a sphere of a radius of 4,000 miles. One city is due north of the other city. Find the distance between Dallas, Texas, and Omaha, Nebraska. Now, if you look at the degrees, minutes, seconds for each of these cities, this is how these cities are measured, especially for like airplanes. I know that when people are flying, pilots use this exact degree to find the city. So this is how that they would use this, okay? Now, if we are assuming that the Earth is a sphere and these cities are due north of each other, here is Dallas, and due north would be Omaha, Nebraska. We need to find this part right here, this arc length S between the two of them. So that's what we're trying to find. Now, before we can do this though, we need to convert our degrees, minutes, and seconds into decimal degrees. So this is what we did a few days ago. Remember that 32 is our whole number. And then we take 47 and divide that by 60, and we get 0.7833. And then we take 39 and divide that by 3600, and we get 0.0108. When we add the two together, then that's what our decimal degrees is. So Dallas has a decimal degrees of 32.7941. Go ahead and convert Omaha on your own. All right, hopefully you got 41.2639 for Omaha. Okay, so we are trying to find our arc length. And if you remember, our arc length is the same as taking the radius times theta. The radius, we were told, is of the Earth is 4,000 miles. And theta, remember, has to be in radians. Well, we don't really know theta quite yet. Theta is the arc, the angle between Omaha and Dallas. So we need to find the difference between these two degrees before we can find the angle theta. So when I subtract the two from each other, I get 8.4, I'm going to round to 8.47 degrees. That is going to be our theta. However, it has to be in radians, so I have to convert. My conversion is to get rid of degrees. Degrees on top, degrees on bottom cancel, and I have 8.47 pi divided by 180. Again, that doesn't make a ton of sense either, so I'm going to take 8.47 times pi divided by 180, and we have a radian of 0.15. This is going to go in here. 4,000 times 0.15 gives us approximately 600 miles. Now, a couple things to make this make sense in your brain. I don't know if many of you have traveled, but from Omaha, Nebraska to Dallas, Texas, that makes sense, right around 600 miles. The other part that should have made sense to you is this angle of 8 degrees. On the globe or on the Earth, Omaha and Dallas are not that far apart, so they are a small angle of degrees apart from each other. A lot to do on that one, from converting to decimal degrees, converting from degrees to radians, and then using our new formula today. Okay, the next formula that we're going to talk about is the area of a sector. sector. A sector is kind of like a piece of a pie. So this part is all of that is the area. This is the formula for the area of a sector. 1/2 radius squared times theta. Again, theta has to be in radians. And that's the question or the problem that I see most kids get wrong, is they keep it in degrees and not in radians. So this is an example of how we're going to use this formula. A sprinkler on a golf course fairway is set to spray over a distance of 70 feet and rotates through an angle of 120 degrees. Find the area of the fairway that it is watered. So if you think about a sprinkler is shooting 70 feet. So our radius is 70 over 120 degree angle. So there's our 120 degrees. We want to know all of this area that is covered by the water as it rotates. So we are going to use area equals 1/2 r squared times theta. We know that r is 70 and theta is our angle at 120 degrees. However, we need that in radians. So we need to convert this to radians. If I want to get degrees out of there, I put that on the bottom, pi on top, degrees on top cancels with degrees on the bottom, and we have 120 pi over 180. Again, go ahead and multiply that out. 120 times pi divided by 180 gives us radians of 2.09. So that is what is going to go in here. And now if I follow my order of operations, 70 squared times 1/2 times 2.09 gives us the area of right around 5,120.5, and this will be labeled in feet squared. Now, we have a quiz at the end of the week. This will be on it, along with the one with Dallas and Omaha and finding out the arc length between the two cities. This is in your homework today, using area. So if you did not copy down these questions, I would go back and write those in your notes so you have something to refer to when you get to your homework assignment. Have a good day.